So this is question 6 from 2.2, the distributive property worksheet. A lot of you have asked me to go over this. I didn't get a chance to go over it in class, so I'm going to go over it right now. I suggest that you open up your notes for 2.2, copy paste this question into your notes, and then write down notes as we go along, just so you have this to study from for a quiz or test. Okay, so this is essentially a word problem. It's got a lot of words in it. First thing you should do is really read through it and make sure you understand the question. Make sure you understand what it's asking and you understand all the words that are in there. All right, so write two formulas. So there's our first indication we need to do something. So write two formulas for the perimeter of a rectangle. Explain how the formulas illustrate the distributive property. So before we can do this, we need to understand what the perimeter is, and we can refresh our memory. So perimeter would be the cumulative length of all the sides of this rectangle. In a circle, the perimeter would be the circumference of the circle. Okay, if somebody asked you to run the perimeter of a field, if this was a soccer field, you would run along the sidelines and you'd run along the perimeter. So perimeter is a length along the outside of an object. So to get the perimeter, you need to add the length of each individual sides. In the case of a circle, there's one side, so the perimeter would just be equal to the circumference, or P is equal to C, where C is the circumference and P is the perimeter. Notice how we're using letters. These are variables, like algebra. Okay, so let's look at our shape right here. We have a rectangle. Now, the question's already assigned certain variables to certain sections of this rectangle. We can see that B looks to be the longer length, and we can say H has been assigned the shorter length. You may or may not have seen lines. These are, I guess, equality lines, just to say that this side and this side are equal, and this side and this side are equal. So, if this side is represented by H, and this side is equal, then this side can also be represented by H. So we can write an H here. Same thing for these two sides. If this side is represented by B, this side is also represented by B because they're equal sides. So let's look at what we have here. If we want to find the perimeter of an object, we need to add all the sides. This side here is represented by H. We need to add that to this side, which is represented by B. So we added these two. So we need to add this side as well, which is represented by H. And then we need to add this side, which is represented by B. So we've added all the sides together. That's what this equation is saying. The perimeter is equal to side H plus side B plus side H plus side B. H plus B plus H plus B would be the perimeter. If the question gave us length, so it said if B equals 10 meters and H equals 5 meters, we can go ahead and use this information to solve the perimeter for this rectangle by substituting those values into this equation. So in this case, every H is going to equal to 5, and we're going to add it to every B, which is equal to 10. Here we have an addition statement. We add it together and we get 30 meters. So we get the perimeter would equal 30 meters. So this is one formula. There are a couple of different ways we can rewrite this formula to show us the same thing, only have it look a little bit different. Okay, the first change we can make is this. You can see I've rewritten the formula over here. These two are exactly the same. I'm going to look at this section of the formula and see if I can change or simplify it or factor it or expand it or do anything along those lines. I can't really do too much right now. But if we can actually simplify, we can squish things together that are like. What we call this is adding like terms. So if we can remind ourselves that a term is a variable or a number that's separated by an operation. So in this case, we have 1, 2, 3, 4 four terms here in this expression, or this equation, sorry. If we look for terms that are related to each other, or terms that are like each other, we can see that we have an H and an H and a B and a B. These are like terms. So the H and the H are like, and the B are like. I'm going to rewrite this expression, this side of the equation, to have those like terms beside each other. Now I like doing them in alphabetical order. You notice how I've written my B's first. So I have B plus H plus H. Okay, so I've rearranged them. This isn't technically a different expression or different equation than this. I've just rearranged the way they looked physically. I've moved them around. But we can combine them now. Doing this allows me to count like terms easier. I notice that I have two b's here. I have one b and one b. I've got two b's. Now, understand that adding variables is different than multiplying. If I had a b multiplied by a b, that would give us our b squared. If you remember, we're adding our exponents that we talked about in class. But we are adding our variables, not multiplying, not doing this. So I've got two b's. They're still positive b's. There's no negative signs in here. I also have two h's. These are positive two h's or plus two h's. So right now we've got a separate equation. I've got p equals 2b plus 2h. There's another formula right there that would do the same thing mathematically, and I invite you to test it. Test this equation like we tested this one here by inputting these values and see if they're the same. We're not done. This is a second one we can have. We can actually do a third one. So to get my third one, I'm going to rewrite my second equation. My perimeter equals 2 multiplied by b plus 2 multiplied by h. And I'm going to try to apply something that we've been learning so far in class. I'm going to try to either expand or factor it. That's kind of annoying because these two birds are in the way, but let's just ignore them, and I think they want some privacy anyway, so I'm going to put a little square over. There we go. Birds have some privacy, and we have more space to write on. All right, so I said we can either factor or we can expand this formula right here. So if we're expanding something, generally you're going to have a number, then a bracket, followed by number variable combination. So something like this we can expand using the distributive property. Oh no, they came back. Let's hide them again. Okay, we're safe. So we can't expand this one. There's really nothing to multiply out, but we can factor it. So looking at our terms here, we've got 2b and 2h. These are our terms. They actually have a common factor, 2b and 2h. So if we list out the factors of these, we can't factor out the letters because there's no letters in common. There's a b here and there's a h here. If there was a b here as well, we can say, well, they have a b in common. All these have in common right now, or the GCF of the number is 2. So 2b and 2h, they have a common factor, and their greatest common factor is 2. So we can actually take that out. We can factor it out by writing it outside the equal sign. So if you remember, when we take out the greatest common factor, we need to divide these constants, these numbers, by that greatest common factor. So 2 divided by 2 would give us 1, or just 1b. Remember, you can include the 1, but you don't really need to include it. So same thing here. We've got 2h. We're going to divide it by our 2, which is our GCF, and we end up getting plus h. So here we have our third equation, or third formula, that we derive specifically from using factoring and applying the reverse of the distributive property. You can apply the distributive property proper by expanding this out by multiplying the 2 back in, and we would just end up getting 2b plus 2h, which is exactly what we had before. All right, so hopefully this helps you a little bit. We've got 3 different formulas here. We've got one over here, one here, one here. We started off with this one here because it was the most logical to follow based on what we know about our perimeter. We then moved to the second one here where we combine like terms to give us this equation over here. Then we took this equation and we factored it out to give us this final one right here. All right, so there's 3 different answers to this question. Hopefully it makes a little more sense. Remember, when you have a word problem, understand the question first and then work through and write down the information that you know. All right, if you have any more questions, send them to me through email. Take a screen clip of anything that's giving you trouble, and maybe I'll make a video if I get enough requests.